Friends, today we will discuss the point that is transport number. I am Dr. S. R. Pujari, Associate Professor, Department of Chemistry, TBF Dayanand College of Arts and Science, Solapur. Transport number, this is a concept particularly used in electrochemistry. We will discuss first the basics of this. When current is passed through a solution of an electrolyte, the positively charged ions move towards negatively charged electrode, while negatively charged ions, that is anions, move towards the positively charged electrode. And thus current is carried, that is transported by the migration of ions present in the solution. So as cations and anions move with different speeds due to difference in their size, the hydration number, the charge, the fraction of the total current carried by each ion will not necessarily be the same, because the charge, size of the ions are different, and therefore they will carry different fractions of current. If you see one example here, always it is true that the faster moving ions will carry a greater fraction of total current, while at the counterpart of it, the slower moving ions, they will definitely carry lesser amount of current. For example, in a dilute solution of lithium chloride, that is LiCl, the lithium plus ions, it carries 0.33 of the total current, while the faster moving chloride ions carry the balance 0.67 of the total current. That means 33% current will be carried by lithium plus ions, while 67% current will be carried by Cl minus ions. Similarly, if you take another example, HCl, dilute solution of HCl. Here, in this case, the faster moving H plus ions, it carries 82% of total current, while remaining 18% of current will be carried by Cl minus ions. Now see here in both these examples, in upper example of LiCl, the size of Li plus is very small, and because of this smaller in size, the hydration number of lithium plus is very high. Because of that, lithium plus ions movement becomes sluggish. Therefore, in LiCl, it is a slow moving ion. While at the contrary, the cation present in HCl, that is H plus, it is very fast, and therefore it carries more amount of current. So that how much of total current will be carried by that particular ion depends upon the nature of electrolyte. The quantitative relationship between the fraction of the current carried by an ion and its speed is expressed in terms of transport number. That is our major point of today's discussion. So transport number, it is the measure of how much of the total current is carried by that particular ion. That is called as transport number. Transport number is also referred as transference number, or even in some textbooks it is referred as Hittorf's number. All these are the same concept, that is called as transport number. If U plus, it represents the speed of cation, while U minus represents the speed of anion. Thus, the current carried by cation obviously is directly proportional to U plus, that is the speed of that cation, while the current carried by anion will directly proportional to the speed of that anion. So as I am interested in the total current carried by both the ions, so obviously that will be directly proportional to U plus plus U minus. Okay. Now the fraction of total current carried by cation and the fraction of total current by anion, how one should calculate this? It's very easy to determine now by knowing the how much current carried by cation and the total current carried by the solution. So T plus, that is the notation used for the transport number for cation, while T minus represents the transport number of anion. So the transport number of cation, that is T plus, is equal to current carried by cation divided by total current carried by the solution, both anion as well as cation. That is, mathematically I can define this as T plus is equal to U plus divided by U plus plus U minus. So the numerator tells me the speed of that cation, while denominator tells me the speed, the summation of speeds of both the ions. Similarly, the transport number of anion is equal to current carried by anion divided by total current carried in total. So T minus is U minus divided by U plus plus U minus, where T plus and T minus has your usual physical significance, the transport number of cation and transport number of anion. So the transport number, it is also referred as transference or Hittorf's number of an ion, is defined as the fraction of total current carried by that ion. Since the two ions carry between them all the current, the sum of the total transport numbers, obviously it must be unity. So that is T plus, that is transport number of cation plus transport number of anion, must be equal to 1. Must be equal to number. So if the transport number of the cation is known, then by subtracting the value of transport number of cation from 1, the transport number of anion can be calculated, and vice versa. So today we will stop here, and